Okay, so really quick, I want to show you guys the idea of difference of means versus mean difference. So we covered this in day one. Okay, this is what we covered first. And so what this does is essentially we have our table here. We're going to take the average of list one. So that's all these numbers right here. Okay, so that average is 5.25. And then we're going to take the average or the sample average of list two, which are all these numbers over here. Okay, so that one was there. That's there. Okay, and that's 5. And what the difference of mean says is we're going to take these two averages and essentially subtract those two averages. Okay, so that's the idea of what's happening with the difference of means. With the mean difference, this is what we're going to cover today. So this is day 2. Okay, what we're going to do is we're going to create a third list where we subtract these two values here. So I say 2 minus 4, and I get -2. 5 minus 9, and that gives me -4. 6 minus 2, that gives me a +4. And 8 minus 5, which is a +3. So I've created a new list, and then all I'm going to do is find the average of these numbers right here. Which in our case gives us 0.25. And so that's the main difference of ideas of what happens with the difference of mean versus the mean difference. Okay, so again, I'll read this and then you'll kind of see what is different with the two. So it says a few people enjoy melted ice cream. Beginning from the sunny state of Arizona, Megan and Jenna decide to test if generic vanilla ice cream melts faster than premium brand vanilla ice cream at 25 randomly selected times during the day and night. The girls put a single scoop of each type of ice cream in the same location outside and waited for them to melt completely. The mean difference is x sub diff is equal to 1.32 minutes, and the standard deviation is 1.14 minutes. Does the data provide convincing evidence at the alpha of 0.05 significance level that the premium brand ice cream takes longer to melt on average than generic vanilla ice cream? So the first thing we do is, again, our parameters. We do need to define what's going to represent mu1 and mu2. Okay, so in this case, again, it doesn't really matter which way you go. I'm going to say the premium ice cream is mu1 and the generic is mu2. And this again is premium versus generic, and this is essentially the time it takes to melt. Okay, so that's what those two represent. Okay, my hypotheses are a little bit different than the other day. So we still have our null hypothesis and we have our alternative. Okay, in this case, we're going to do mu, and then we're going to use the subscript of diff for the mean difference. So that's all that describes, the mean difference. And this one will always equal 0. So imagine us, again, doing what we did in that first video, and it should equal 0 if there's no change, right? And so then here, my alternative hypothesis I get from this last sentence. We're looking to see if the premium brand vanilla takes longer to melt than the generic. So we want to know the mean diff, still going to be 0. And if I were to subtract these two, M1 minus M2, right? If it takes the premium longer to melt, that means this, whenever I did that subtraction, would give me a positive number, okay? Because this number would be the bigger number. So the difference of those two should give me a positive value. And then my statistics, okay, for this one, we have the mean difference, okay, which is 1.32. Okay, that I got from here. Significance level is 0.05. And then this is where things change. We're going to use just the t-test on our calculator. Okay, and I'll run those numbers here in a second. Okay, and so when we run the t-test, I'm going to have to know the null mean. Okay, I'm going to have to know essentially X bar, the sample average. I'm going to need to know the standard deviation, and I'm going to need to know the sample size. Okay, all of this should be provided. The null mean I get from my null hypothesis. So that is going to be 0. The sample average that we got was 1.32. The standard deviation was 1.14. And then, excuse me, the sample size was 25. Okay, and so since I'm running the t-test, I'm looking for the t-statistic and the p-value. Okay, so let's go to our calculator. So we go to stats, we scroll over to tests. This is number 2, just t-test. Okay, I have the stats, so I make sure that's highlighted. The null mu is 0. This was 1.32. Standard deviation, 1.14. And the sample size is 25. Okay, and then we had the mean difference should be greater than, and then we hit calculate. Okay, and so those are my two values that I need to have. So we have 5.79 and essentially a p-value approximately equal to 0. Okay, don't forget because of the e right here, e to the -6. And then I just conclude. We can simply say, since the p-value is small, we reject the null hypothesis. We do have evidence to support that premium ice cream takes longer to melt. Okay, so if you're given the statistics, no big deal. We run the test that we did in chapter 7. Okay, and then let's do this next one. Okay, this one is going to be a little different because we're given the data. Okay, and I'll show you how to do that on our calculator. So it says for their second semester project in AP Stats, Libby and Catherine decide to investigate which line was faster in the supermarket, the express lane or a regular lane. To collect their data, they randomly selected 15 times during a week, went to the same store and bought the same item. One of the students used the express lane and the other used the closest regular lane. To decide which lane each of them would use, they flipped a coin. They entered the lanes at the same time, paid with the same method, and recorded the time in seconds it took them to complete the transaction. Carry out a test at an alpha of 0.05 significance level to see if there is convincing evidence that the express lane is faster. Okay, so again, pretty simple. We need to identify our parameters. We have a mean. I just make the top one mu1, the bottom one mu2. Okay, I will restate this over here. This is just the time in the regular line, and this is time in the express lane. Okay, and so again, I'm going off the assumption that I subtract those two. Okay, if there was no change, that should equal 0, right? But I'm going off that assumption. So that'll help me when I'm writing my alternative hypothesis. So my hypothesis, null hypothesis, is the mu difference is equal to 0. That means there is no time change. The fast lane doesn't take less time, right? And then my alternative has to match up with what they want to know. So we want to know if the express lane is faster on average. So that means when I subtract those two, okay, if I do mu1 minus mu2, then I should have a positive number because I'm taking the time in the regular lane, which should, in theory, be a bigger number, minus the time in the express lane, which in theory should be a lower number. So I still should have a positive number. So it's greater than 0. And then here, again, the stat will be essentially that, right? I'll find that here in a second. So I'm just looking for the difference of that. I'm not going to know that until I calculate everything I need to calculate. Significance level is 0.05. Okay, name of this plan is still t-test. Okay, and then we do all this calculations. I'm still looking for T and P. Okay, and so here's what's different on the calculator. All right, so the first thing we have to do is we have to go to stat edit. Okay, and this is on that first column of the kind of summary sheet of this. Okay, and it tells you that we have to calculate an L3. Okay, so the first thing we do is we put in every value into list 1. So this is all the times from the regular lane. Last one there. And then this in L2, we're going to put in the time for the express lane. Okay, so I've calculated, again, I've entered in, regular time, fast lane, and then it says calculate a list 3. So here's what I do. I scroll up to where L3 is highlighted. And then what I'm going to do is I'm going to subtract L1. So I hit second and 1 to type in L1, and I subtract that value from L2. So again, second, and then hit the number 2, and you'll get list 2 in there. And then all I have to do is hit enter. And when I hit enter, all those values calculate. Okay. And so what we're going to do now is we're going to go back and run our test. Stat, scroll over to test, and I'm scrolling down to number 2, t-test. This time I have data Okay. The null mu should be 0, and then the list I have to change. I want to use the values in list 3, okay, the mean difference. So that was what I'm doing. So I changed this by hitting second and number 3, and it changes to L3. And that's what I changed there. Again, I make sure that this matches up with the correct symbol. So we have greater than, and then all I do is hit enter. Gives me my t value, it gives me my p value, it also gives me my average. Okay, so 42.67 essentially. So 42.67 goes here. Okay, the t was 1.9668, the p value 0.0347. And then again, I conclude. Since the p-value is small, we reject the null hypothesis. We do have evidence to support that the express lane is faster. Okay, and then this will be the last example I do. The next example is going to be confidence interval, but we do it the exact same way we just did this one. So now you're going to get a lot more data, right? So we have confidence interval for the mean difference. It says researchers designed an experiment to study the effect of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for a duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the subjects took caffeine and the placebo was randomized. At the end of each 2-day period, a test of depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table contains data on the subjects' scores on the depression test. Higher scores correspond to more symptoms of depression. Construct a 90% confidence interval for the true mean difference in the depression test scores for subjects like these. So again, easiest thing to do is define this as mu1 and this as mu2. So we have mu1 is essentially caffeine, okay, and mu2 is placebo. Okay, and again, this is the essentially depression. So depression scale, okay, with caffeine and without. With our statistics, again, we're just going to have that. We'll have to calculate that after we use the calculator. We want a confidence level of 90%. Okay, with this, we're going to use a t interval. Okay, and so when we go into our calculator, again, we have to stat edit. We can clear these lists. Okay, even 3. And then we have to insert those lists. So we have, okay, and so I put in my 2 lists. I calculate list 3, Again, I just always do list 1 minus list 2. Calculate that. This time when we're running this test, it is going to be number 8, because that's the t interval. Okay, I have data. It's awesome because my list 3 is already in there. If it wasn't, you would change that to list 3. Keep frequency the same. We want 0.90 as my confidence level, and then I hit calculate. Okay. And so there's my data. So I come over here. My average was negative 7.36. Okay, my interval was negative 11.144 and negative 3.583. Remember, that's what we got. This was essentially me subtracting mu1 minus mu2. Remember, there's another answer. If you were to find it the other way, say we did mu2 minus mu1, again, you would still be correct. These would just kind of flip and change to the positive. Okay, and again, it doesn't matter which one you use. And then when we conclude, we have our sentence stem. We are 90% confident that the interval from negative 11.14 to negative 3.58 captures the true mean difference of depression in people that had caffeine versus those who had a placebo.